Today our last video of our series design a key value store. Today we'll talk about the system diagram, and we'll talk the write and read path and how they work. So let's just start quick. Before I start, I just wanna say, if you didn't watch the previous video, I highly recommend them. I recommend you to watch them. I guess I will not make a recap because a lot of you guys said that recaps waste a lot of times, maybe 5 6 minutes, so it just wastes a lot of time. So I'll just go in the video just straight ahead. So that's it basically. So let's just start in the system architecture diagram. And inside the system architecture diagram, first of all, the start with we have the client, and the client is trying to connect it with the database. It will connect with the server node with N6, and N6 is a coordinator, and the coordinator basically it's acted as a proxy between the client and the replicas. And what a proxy is in the computer networking, a proxy acts as an intermediate between the clients and servers. It's it provide various functionalities. It sits between a client and the target server, and forward client's request to the appropriate server while handling the response. Proxies also can be deployed for different purposes, but for now let's just understand that the proxy are intermediate. It's something that acts intermediate between the client and the server. Um, After that, we have, you call it, the client will connect with the coordinator or the proxy, and the proxy will act as an intermediate between both of them, and it will distribute the nodes on the ring. Right now we are sorting our nodes on a hash ring. It will sort them in the ring, and it just distribute sorry, it will not sort it. It will distribute the requests on the ring. The system is completely decentralized, so adding and moving nodes can be automatic or can be easy because we are using a consistent hashing. Data is replicated at multiple nodes. We have something which we call its virtual nodes. Also, we have virtual nodes. It's and data replicate multiple nodes. For example, when we have a key value store, we store it in N0, N1, N2, and we have maybe centralized data. We also replicate this data into multiple centralized data to make sure that we have no rows and we have multiple availability, and we have no single point of failure. And if we and this is how the system works on a high level design. And this is the diagram. And let's just talk about the right path. So in the right path, if you can see right now, the client will connect, will try to store the write request. It persists to a commit log. So this is one. 1 minute. Let's just text. This is one, and I'll just make it bigger. Okay, and this is two. No, 2, and this is 3. No, and this is 3. Okay. So the write request is persist on a commit log file. But what is a commit log? In for example, this diagram we're using from Cassandra. So in Cassandra, in Apache Cassandra, the commit log plays a crucial role in ensuring data durable and recovering from system failures. The commit log is a write ahead log that records all write operations before they are applied to the actual data files, and it serves as a persistent and a sequential log of write operation. So this is what is the commit log and the purpose of the commit log. And after that, we save. After we write the things to the commit log, we save it to the memory cache. And when the memory cache is full, we reaches a predefined, maybe like when memory cache was full, we are storing the predefined or the remaining data into something that we called um, an SS table, and in the context of database and storage systems, SS table, it's what is short for sorted string table. It's an disk data structure used to store and manage sorted key value pairs effectively and efficiently. It's a popular sorted format utilized by various distributed and NoSQL databases, including Apache Cassandra. So just make sure that it's like that. And of course, we have the memory and the disk, and the table it's a disk, so we store in disk. After that, we talk about the read path, and the read path is we have the read path right now. The client will try to connect to the memory cache. If the client finds the data in memory cache, it will just get it right away. However, if the memory doesn't have the data, the system first check if data in memory cache. If it's not, we go to step 2. So this is step 1, and this is step 2. No. And this is step 2, and this is 3, this is 4, and we're returning back. So if data is not the memory cache, the system check the Bloom filter. And what is a Bloom filter? A Bloom filter, that when because we are sharded our because we sharded our data, we want to know which SS tables that we are going to connect to. We're using a Bloom filter, and the Bloom filter is a space-efficient probabilistic data structure used to quickly determine whether an element is a member of a set of table. For example, it provides an efficient way to test set membership, especially when the false positive, including things like that. So we want to know if if this element is in this specific table, so we use a Bloom. So if the Bloom filter is used to figure out which table SS tables might contain the key, the SS tables return the results of the data set. The results, as you can see, result data returns back to the client, and that's it. And I want to say congratulations for watching all of that. It was a long journey, and if you like my content, make sure to subscribe, hit the notification bell so you will never miss a video, and see you in future video and future series.